Okay, in today's lesson, we are going to learn about the chain rule. So, the chain rule is used to differentiate composite functions. So, the first thing we are going to learn about is the composite functions. So, a composite function is defined like this. So, given two functions f and g, the composite function has this notation f circle g and is defined by this. So, the composite function is defined like this. It's a function inside of another function. So there's an outer function which is the f function and the inner function which is the g function. So think of this new type of function as a function inside of another function. So we have f, which is the left function, which is the function that acts as the outer function, and g, which is the right side function that acts as the inner function. So g is inside of f. So this type of function is called a composite function. So for example, if I wrote g circle f, then the outer function is g, the left hand side function, and the inner function is f because it's the right side function. Okay. So similarly, you can define f circle f. So here the outer and the inner functions are both f. So these types of functions are called composite functions. And to differentiate these types of functions, we use the chain rule. Okay. So to apply the chain rule, the first thing you need to decide is what is the outer function and what is the inner function of the given composite function. So let's do a couple of examples on how to decide what is the outer and what is the inner function of a given composite function. So in this first example, my function is x minus 2 raised to the 10th power. So this is similar to what? This is similar to x to the 10. So this is similar to a power function. So in a power function, 10 is the outer function, or the power is the outer function. So this acts as a power function, and the outer function is the power, and what's inside here is the inner part. So here the outer function is the power part, and the inner function is whatever's inside there. So that's x minus 2. So this is important because the chain rule depends on the outer function part and the inner function part. Okay, let's see the second example. So the second example is an exponential function. So in an exponential function, the general definition of the exponential function, we put numbers into the exponent t. So t acts as the inner part because we are putting something inside that to find a value. And e is the outer part, which is the exponential part. So here e acts as the outer part, and the exponent, where we put the number or whatever expression we have, is the inner part. So for this function, the exponential function part is the outer part, and the exponent is the inner function part. Okay. And the final example, we have a trigonometric function, the sine function. So if you recall, normally to find something, we put some value here, some angle or some expression. So what you put inside of sine is the inner part, and you are putting it inside sine, so sine is the outer part. So the outer function is sine, The inner function is whatever you put inside here. So that's 3 minus x. Okay, so now that we know how to identify composite functions and the outer and the inner parts, now we can see how we differentiate these types of functions. So to differentiate these types of functions, we use the chain rule. So to differentiate composite functions, the rule we use is called the chain rule, and it's given by this expression. So we have the composite function with the outer function and the inner function, and then the derivative is given by this expression. So the first term depends on the outer function. So outer function is f. So the first term of this derivative expression depends on the outer function. So it's the derivative of the outer function evaluated at the inner function. So f prime. So the first term of the formula depends on the outer function, which is f, and you need to find the derivative of that outer function, evaluate it at the inner function, which is g. Then the second part of the formula depends on the inner function, which is g. So the second part is just find the derivative of the inner function. Then multiplying these two terms, you get the complete formula for the derivative of a composite function. And this rule is called the chain rule. So that is why it's important to know what's the outer function and what's the inner function. Okay, so let's do a very simple example to show you guys how to apply this rule. So suppose we want to find the derivative of this. So we want to find the derivative of x minus 2 raised to the 10th power. Okay. So if it was like this, instead of x minus 2 to the 10th, if it was x to the 10, we can easily find the derivative using the power rule. Remember, that's just 10 times x to the 9 using the power rule. So the reason we can't use the power rule here is because it's not x inside, it's x minus 2. So this is a composite function, but the derivative will depend on the power rule because it's similar to x to the 10th, and we can find that derivative using the chain rule and the power rule. So first we identify the outer function and the inner function. So the outer function is the power part, the inner function is x minus 2. Then the derivative using the chain rule. So the first part is what? The first part is the derivative of the outer function. So the derivative of the outer function is just a power. Think of, so what, think of what's inside as x. So then x to the 10th, when you differentiate, it's 10 times x to the 9th. But instead of x here, you need to put the inner function inside. We are evaluating the derivative of the outer function at the inner function. So instead of x, you need to put x minus 2, whatever the inner function value. So that's the first part. Then the second part is the derivative of the inner function. So find I prime, which is what? 1. Derivative of x is 1, derivative of negative 2 is 0. So now just simplify this, you get 10 times x minus 2 raised to the 9. So you see the two answers are very similar, and we can get the same answer, the correct answer, using the chain rule. Okay, so this first term is the derivative of the outer function evaluated at the inner, and the second term is the derivative of the inner function. So that's the formula. So that's how you use the chain rule. Okay, we will do a couple of more examples to explain this rule more. Okay, so this one, we want to find the derivative of this function fx is equal to 3x minus 5 to the 100. So this is similar to x raised to the 100, and we know how to differentiate x raised to the 100 using the power rule. It's 100 times x to the 99. So the reason we can't say this is the correct answer, because it's not x inside. The inner part is 3x minus 5 and the outer is the power. So then you need to use the chain rule. So the outer function is the power, the inner function is 3x minus 5. So then the derivative of this function is, first find the derivative of the outer function, this one. So it's like this part without the x. Instead of x, you need to write the inner function inside. So 3x minus 5. So you don't mess with the inner part in the first term. You just keep the inner the same. Then the second part of the chain rule is you multiply by the inner function's derivative. So the derivative of 3x is 3, derivative of minus 5 is 0. So 3. So to get the final answer, just simplify this: 300, 3x minus 5 to the 99. So once you identify the outer and the inner, it's very easy application. So the first term is made up of the derivative of the outer function evaluated at the inner, and the second term is the inner function's derivative. So when you multiply these two, you get the answer using the chain rule. Okay, let's do a couple of more examples. Okay, the next example is using the exponential function. So we want to find the derivative of g of t is equal to e to the phi t, and we know how to differentiate the exponential function e to the t. It's the easiest formula to remember. The derivative of e to the t is e to the t, the function itself. So the only difference is our inner part is not t, it's phi t. So because of that, we need to use the chain rule. So here, my outer function is the exponential part. The inner function is the exponent phi t. Then using the chain rule, you first find the derivative of the outer function. So the derivative of the exponential function is the exponential function itself. And instead of t, you need to write the inner function inside, so phi t. So that's the derivative of the outer function evaluated at the inner. Then the second part is you need to find the derivative of the inner function. So here it's just 5. So let's move the constant to the front. So that's the final answer. So this part was the outer function's derivative evaluated at the inner, and the second term is the inner function's derivative. Okay. Then the last example we are going to do is this one. And this is a special example because we need to apply the chain rule twice here. instead of once like the previous example. So for this question, I will need to apply the chain rule twice. Okay, so let's see. This is the function given to us. Then the outer function is the exponential function, and the inner function is the exponent, the full exponent, this one. So the outer function is e raised to something, and the inner function is the exponent 2x squared minus 3x to the fifth. Okay. Then the derivative is, the first part depends on the outer function. You find the derivative of the outer function. So the derivative of the exponential function is just the exponential function itself, and what's inside is the inner function. So 2x squared minus 3x raised to the fifth. So that's the first part of the chain rule. Then the second term of the chain rule is the derivative of the inner function, I prime. So we need to find I prime. And if you look at I, there's no direct formula I can apply. But here, this is an application of the chain rule again. So the outer function is a power, and the inner function is 2x squared minus 3x. So I can say, let's say O1 is the outer function of this one, and I1 is the inner function. Then O1 is the power function part, and the inner function is 2x squared minus 3x. So then I prime is, you take the derivative of the outer function first, this one. So 5 comes down and you subtract one power, so the power becomes 4, and inside you need to write the inner part, which is 2x squared minus 3x, and times I1 prime. And what is I1 prime? The derivative of 2x squared is 4x, derivative of negative 3x is negative 3. So I1 prime is 4x minus 3. So I prime is equal to this one. So we had to use the chain rule here to find the derivative of the inner function. So that's the second application of the chain rule. We already applied the chain rule here to get this expression. So we need to apply the chain rule twice to get the final answer. So once we have I prime, sub it here and you get the final solution. So e raised to 2x squared minus 3x to the fifth, I prime is equal to 5 times 2x squared minus 3x to the fourth times 4x minus 3. So that's the final answer. So here we had to use chain rule twice. So in some questions you need to use chain rule more than once. Okay. So I will stop the lesson here today. Okay, see you guys next time.